We are still on angles of elevation and depression. The question here says from a horizontal distance of 10.5 kilometers, a pilot observes that the angles of elevation, angles of depression of the top and base of a control tower are 36 degrees and 41 degrees respectively. Calculate the shortest distance between the pilot and the base of the control tower. Roman figure 2 says the height of the control tower. Roman figure 3 says we should calculate the shortest distance between the pilot and the top of the control tower. So we'll go back to the first statement there. It says from a horizontal distance of 10.5 kilometers, okay, a pilot observes that the angles of depression of the top and base of a control tower are 36 degrees and 41 degrees respectively. Okay, so we assume that this is the plane. We assume this is the plane. And then over here is the tower. Okay, so of course the pilot should be here in the plane. Now it says from a horizontal distance of 10.5 kilometers, the horizontal distance is this 10.5 kilometers. Okay, so the pilot should be in this plane, and then this should be the tower. Okay, so that is it, the tower. This is the ground level, and morning. Okay, so we have that the distance between the pilots and then the point of the tower on the horizontal plane is 10.5 kilometers. So we are told a pilot observes that the angle of depression of the top and base of the control tower 36 degrees and 41 degrees respectively. We take this distance from here to the top of the tower, and then we take the distance from this point of the pilot to the base of the control tower. Okay, to the base of the control tower. So first thing we'll look at the angles of depression of the top with respect to the control tower. This is it. The angle of depression is 36 degrees. Okay, with respect to this control tower, this is the top of the tower T, and the base of the tower we can call the base of the tower R. Okay, and then the angle of depression of this pilot with respect to the base of the tower is 41 degrees. So the angle of depression there is 41 degrees. So if you observe, this is the angle of depression of the top of the tower. Okay, that is angle of depression 36 degrees with respect to the top of the tower, and angle of depression is 41 degrees with respect to the base of the control tower, 41 degrees. Okay, all right, so that is it. Now if this angle of depression here is 36 degrees, it will alternate here. Taking alternate angles, it will alternate here as 36 degrees as well. Okay, and then if this is 41 degrees here, this will alternate here as 41 degrees. Alternate angles. Right, since we observe that this is the line connecting the pilot and the top of the tower. So if this is 36 degrees, then here is also 36 degrees, alternate angles. And this one is 41 degrees, then this angle here will be 41 degrees. Okay, so they are alternating. Alright, so this is what we're having, 36 degrees alternating here as 36 degrees. Then now you see that this angle here is 90, angle 90 is 90 degrees. That means if I add this now, this angle now, I'll be having 36 plus 90, which will give me 100 and so to give me 126 degrees. Right, so this angle is 126. This angle here is 126 degrees. Okay, so this angle is 126 degrees. All right. Now the next thing they say we should find is the shortest distance between the pilot and the base of the control tower. That is distance. If I say this point is x, that is distance from x to arrow. This is the base. This is the base of the control tower. As we look for distance x arrow, we find distance x arrow. Then we also asked to find the height of the control tower. The height of the control tower is distance from T to arrow, which is the height h. The height of the control tower, we'll look for that. And then secondly, next thing we'll look at there is the shortest distance between the pilot and the top of the control tower. Shortest distance between the pilot and the top. So from here to here and the top of the control tower, that is distance xt. Shortest distance between the pilot and the top of the control tower. Then shortest distance between the pilot and the base of the control tower is x arrow, and also the height of the control tower. Alright. Okay, so this is the diagram we're having. Observe, this is the diagram we have. Okay, that's the diagram. Now I can extend this line from point T, extend it upward using dotted lines. That is, using dotted lines now. Using dotted lines, I then extend this. This is the horizontal distance, 10.5. Okay, so from here now we use dotted lines and extend it upwards. And then I can call here y. I can call this point y, because this will be angle 90. Okay, so this is the diagram I'm having now. So from point T, I used dotted lines and I extended it upwards. Okay, and I call that point y. Okay, so I can then take from triangle x, y, t. From triangle x, y, t, say from triangle x, y, t. Okay, if I then cut it out, I'll have something like this. That is x, y, and t. Alright, so this at point x, the angle is 36 degrees. And here is 10.5 kilometer. Okay, then I can then find this distance. I can choose to find this distance. That's distance xt. I can find this distance xt. And likewise, I can also find yt if I choose. If I want, I can find yt. Okay, so this is 90 degrees, isn't it? Now the side facing angle 90 is my hypotenuse side. And the side that faces, this side facing the angle of inclination, is opposite. So here now becomes my what? Adjacent. Okay, so to find this side now, if I have adjacent and hypotenuse, I'll use a car. That is, don't forget this. So car. Don't forget this acronym. The acronym is that of the basic trigonometric ratio, and to help us in solving problems. So I use car. Car is cosine of angle is equals to adjacent of hypotenuse. So that is adjacent side divided by the hypotenuse, and I'll be having a cos 36 degrees. So I'll be having cos 36 degrees. Cos 36 degrees equals to adjacent over the hypotenuse. And my adjacent side from that diagram, the adjacent side is distance xy. Distance xy. My hypotenuse is distance xt. Distance xt is the hypotenuse side. Okay, so I can say cos 36 degrees is equals to distance xy is 10.5. 10.5 divided by distance xt is unknown. Xt is unknown, so if I interchange position, I'll have xt is equals to 10.5 divided by cos 36 degrees. Okay, so distance xt now will be equals to 10.5 divided by, look for cos 36, I'll have, this will give me 0.809. So that means distance xt will be equal to 10.5 divided by 0.809 will be, okay, this will give me 12.98 meters. Kilometers, sorry, it's kilometers. 12.98 kilometers. Yeah, the dimension is in kilometer. Okay, that is it. That's the dimension in kilometers. So that is 12.98 kilometers. So I've already gotten the first one, the shortest distance. I've gotten the shortest distance between the pilot and the top of the control tower. Shortest distance between the pilot and the top of the control tower is distance xt. I've gotten distance xt, so I can say, so therefore shortest distance between pilot and top of control tower is 12.98 kilometers. Okay, that's 12.98 kilometers. All right, so if I want to find this distance yt, to find distance yt, I can say opposite over adjacent, that's tangent, that is tan 36 degrees using 12, that's tan 36 degrees. Tan 36 degrees will be equals to the opposite side over the adjacent side, which is my opposite side is yt, distance yt. My adjacent side is xy over xy, which will give you distance yt is unknown, and xy is 10.5. It's 10.5. So if I cross multiply and I have what, yt is equals to 10.5 tan 36 degrees. Okay, that's when I cross multiply 10.5 multiply tan 36, and then I'll have 10.5 tan 36 degrees. Now using my calculator, I will find tan 36 and have yt is equals to 10.5 times. We're looking for tan 36 now. Have okay, so this will give me 0.7265. okay, that is tan 36 is 0.7265. Now if I multiply it now, so I'll be having distance yt is equals to, and I multiply, I'll have that is 7.628 kilometers, which is approximately 7.63 kilometers to two decimal places. I'll have that. That's distance yt. Distance from point y to point t. We solved it. Distance yt is that's 10.5 times 36, which gave us 7.628. We approximated it and have 7.63 kilometers. Okay, now we have gotten that. Now distance yt, we have gotten that, and we have also gotten distance xt. That's distance between the pilot and the top of the control tower. Now let's continue. Alright, now let's come back to this diagram. This is the diagram we're having. Okay, observe this diagram closely. Now if here is 41 degrees, what is this angle? This angle now, 90 minus 41. This is 90 minus 41. This is 49 degrees. So this angle is 49 degrees. Okay, if here is 41, here will be 49. When you add them, you have 90. So let's come back to this other one. If here is 36 degrees, of course, we can find this other angle. 36 degrees, you can find here. Like this. Okay. Now, okay. Okay, this side is 41 degrees. Okay, that's it by the way. Let's hold on. Suspend it there. Okay. Now I can cut out triangle XT arrow. Cut out triangle XT arrow. Say from triangle XT arrow, if I cut it out here, and here, if I section it out now, I will have something like this. From triangle XT arrow, that will be, say, from triangle XT arrow. From triangle XT arrow, this is point X, this is point T, and this is point arrow. Okay, this angle here is 126 degrees, and as angle at point T, that's this one. Angle at point T is 126 degrees. Angle at point arrow is 49. It's 49 degrees. Okay, Then we'll then find this other one. Finding that one will not be an issue. Use the sum of angles in a triangle. Okay, use the sum of angles in a triangle. That will be, okay, you take the sum of angles in a triangle. That is angle at point X plus angle at point T plus angle at point R is equals to 180 degrees. This is what? Sum of angles in a triangle. Sum of angles in a triangle, which is angle at X is unknown plus angle at T is 126 degrees plus angle at R is 49 degrees is equals to 180 degrees. So now angle at X now will be equals to 180 minus 126 degrees plus 49 degrees. Okay, that's when I collect like terms. Carry this over here. Take these two angles, take them over here to be minus. So angle at X now will be equals to 180 minus, if I add them now, what will I have? Add those two. So this will give me 175 degrees. Okay, so when I then add them, I'll have angle at X as I subtract them now, I'll be having 5 degrees here. Okay, so angle at X, 180 minus 175 will give me 5 degrees. Okay, so observe it. That means that small angle there, angle at X is 5 degrees. Okay, this is 5 degrees here. It's 5 degrees. So the sum of angles in a triangle will give you 180. That's 5 plus 126 plus 49 to give you 180 degrees. So I've gotten that. And then we had the distance xt. We had distance xt. Remember, distance xt as 12.98. So distance from here to here is 12.98 kilometers. And this one now is the height of the control tower. And this one is distance x arrow unknown. Distance x arrow is unknown. That's the distance between the pilot and the base of the control tower is unknown. So we are going to solve them. Now if this is capital X, the side facing here is small x. This is capital T, the side facing this side is small t. If this is capital R, the side facing here is small r. Okay, so that we can then use sine rule, and solve and get your final answer. Okay, so we use sine rule, and solve it. Okay, now that will give us okay, so using sine rule from that diagram, we apply sine rule to that diagram, and we'll have so using sine rule, we'll be having sine x over small x is equals to sine r over small r is equals to sine t over small t. Okay, so that is it. Okay, so that is sine angle at x. Angle at x is 5 degrees. Small x is h, which is the height of the control tower. Angle at r is 49 degrees. That's sine 49 degrees. And the small r is 12.98. Angle at t is 126 degrees. That's sine 126 degrees. Then small t is distance x arrow, which is unknown. That is the distance between the pilot and the base of the control tower. Okay, so you can compare this to this, and then compare this to this. Let's come back to that diagram so I will know how I got this. Angle at x, if you observe, angle at x is 5 degrees. Okay, that is sine 5 degrees over small x is h. That will be sine 5 degrees over h. Then angle at arrow is 49 degrees. That is sine 49 degrees over small arrow is 12.98. That is sine 49 over 12.98. Then angle at t, capital T, angle at t is 126. That's sine 126 over small t is x arrow. That is it. So that's I had sine 126 over x arrow. Alright. Okay, let's continue. So this will give me sine sine 5 degrees over small h is equals to sine 49 degrees over 12.98. Okay, when I cross multiply, if I cross multiply, observe, please, this is what I did. I compared this and this, sine 5 over h, compare it with sine 49 over 12.98. okay, and when I'm done with these two, I will then compare this with this so I can find xr. Alright, okay, so I compare these two. Right, so if I cross multiply this will multiply this, that will give me h sine 49 degrees equal to this one multiply this one, that will be 12.98 sine 5 degrees. So divide by the coefficient of h, which is sine 49, h will be equals to 12.98 sine 5 degrees divided by sine 49 degrees. Okay, so h will be equals to 12.98 times sine 5 will give me 0.087 divided by sine 49 is that is 0.755. okay, so that means h now will be equal to, when I multiply 12.98 times that is this is 1.1293 divided by 0.755. okay, so when I divide it now, 1.1293 divided by 0.755 will give me, so when I divide this now, I'll be having that h is 1.496 kilometers. Okay, that's the height of the control tower. I can say therefore the height of the control tower is 1.496 kilometers. Okay, it's 1.496 kilometers. That is the height of the control tower. The height of the control tower is 1.496 kilometers. Now let's look for the distance, the shortest distance between the pilot and the base of the control tower. That is distance x arrow. Now what do we do now? We compare this with this so that we can find distance x arrow, the shortest distance between the pilot and the base of the control tower. Now when I compare this and this other one, I'll be having I'll have sine 49 degrees divided by 12.98 is equivalent to sine 126 degrees divided by distance x arrow. Okay, now what I do is to cross multiply. If I cross multiply, I'll have this times this will give me x arrow sine 49 degrees is equal to this one multiply this one, that's 12.98 sine 126 degrees. So this will multiply this and this one multiply this one. Now I'll divide by the coefficient of x arrow. The coefficient of x arrow is sine 49. That will give me, okay, if I divide by the coefficient of x arrow, I'll have distance x arrow is equals to 12.98 sine 126 degrees divided by sine 49 degrees. Okay, when I divide that, I have distance x arrow is equals to 12.98 multiplied by sine 126 now will be, this is 0.809 divided by sine 49 will give me, this will give me 0.755. So when I multiply this now, it will be distance x arrow will be equal to this times this will give me, so this will give me 10.501 divided by 0.755. That will be equal to, that's when I multiply 12.98 times 0.809, it gave me 10.501 divided by 0.755. That will be, so when I divide this will give me 13.91 kilometers. Okay, 13.91 kilometers. This is the shortest distance between the pilot and the base of the control tower. So I will indicate that. I'll say, therefore, shortest distance between the pilot and the base of the control tower is 13.91. So therefore, the shortest distance between the pilot and the base of the control tower is 13.91 kilometers. That's 13.91 kilometers. Alright. Now there is another method you can use in solving this problem. This is the diagram. Observe the diagram. There is another method you can use in solving it. Okay, so let's look at method 2. Method 2. The next approach on how you can solve this problem. Okay. You say alternatively, that is method 2, using the second approach. Okay, alternatively using the second approach. Now I can take first take this triangle XYT. I say from triangle XYT, from triangle XYT, if I cut it out, I'll have something like this. Triangle XYT. This is it. Triangle XYT, X, Y, and T. And this angle here, angle at point X is 36 degrees. This is 90. Here is 10.5 kilometers. And then this distance is XT. Alright. And here is YT. Distance YT. Okay. So what now do I call this side my hypotenuse side, and this side is adjacent. Here is opposite to this angle. So I'll find this side, and then I'll also find this side. Now considering the hypotenuse and the adjacent side, I'll say cos 36 degrees is equals to adjacent over hypotenuse, which is equals to the adjacent side is distance XY. My hypotenuse is distance XT. So cos 36 degrees is equals to distance XY is 10.5 divided by distance XT is unknown. Okay. Now if I interchange positions, this will come here, this one come down. I say distance XT is equals to 10.5 divided by cos 36 degrees. So distance XT will equals to 10.5 divided by cos 36 will give me 0.809, and distance XT now will be equal to, divide this now, have this will give me 12.98 kilometers. Okay, distance XT is 12.98 kilometers. Okay, so I've gotten this distance between the pilot and the top of the control tower. I've gotten it. That's distance between pilot and top of control tower is 12.98 kilometers. Okay, so I've gotten the answer. Now the next thing I'll then look for is distance YT. So I have the opposite side and the adjacent side. That's tangent. You can say tan 36 degrees is equals to opposite over adjacent, which is my opposite side is YT, and my adjacent side is XY. Right? That is it. Opposite is this, adjacent is distance XY. So now that will be equals to YT divided by distance XY is 10.5. So if I interchange position, or rather I'll just cross multiply. This will multiply this. I'll be having what? Distance yt is equals to 10.5 multiplied by tan 36 degrees. Okay, so that is 10.5 times tan 36 will give me, tan 36 will be, this will give me 0.727. that is 10.5 will multiply that, and I'll have 10.5 will multiply that, and I'll be having so this will give me 7.634 kilometers rather. Okay, that's when I multiply, that's what I'll have. Okay, that's 7.634 distance yt. Now that is what is giving me. Now I can then continue, and then I'll have can take the full triangle, triangle x y arrow. Now initially I cut out this triangle, Now the next case, now take the full triangle, that is from x to y then to arrow. I'll cut everything out. The full triangle, I say from triangle x y arrow. If I cut the full triangle, I'll have this x y arrow. Here is 90 degrees, here is 41 degrees, and here is 49 degrees. Okay, so distance x y is 10.5 kilometers, and distance y arrow now will be this distance from here to here plus here to here. Okay, and we have gotten yt. We had yt at 7.634 kilometers. Abi? Okay, so we had this at 7.634. So distance yt plus t arrow, that will be 7.634 plus what? H. Okay, this now will be 7.634 plus h. Alright, so that is the distance. That's distance from y to arrow. From that diagram, distance from point y to arrow will be the total distance 7.63 plus h, and the h is the height of the tower. Okay, so this distance x arrow is unknown. We assume this to be unknown. Now this side facing angle 90 is the hypotenuse side. Take that as the hypotenuse side, and then the side facing the angle of inclination, if this is the reference point, the angle of inclination here is 49 degrees, so here is opposite, and then we take here as the adjacent side. So we are making use of this angle 49 degrees. This side is opposite to this angle of inclination. Okay, and then here is the adjacent side, that is the distance y arrow becomes the adjacent side. Alright, so you still make use of the basic trig ratio, that is SOHCAHTOA. Let's find the hypotenuse side now using the opposite and the hypotenuse. That is sine 49 degrees will be the opposite side divided by the hypotenuse side. Okay, so I say sine 49 degrees is equals to opposite over hypotenuse, which is the opposite side is distance xy, and the hypotenuse side is distance x arrow. The distance x arrow. Okay, so distance xy is 10.5 kilometers. That is 10.5 kilometers divided by distance x arrow is unknown, which is or the unknown points. That's x arrow. Now what I'll do is to cross multiply. This will multiply this, and then 10.5 will multiply the denominator of sine 49. Okay, so that is x arrow times sine 49 degrees, and the denominator of sine 49 is 1. 1 will multiply this 10.5, and I'll have 10.5. When I divide by the coefficient of sine of x arrow, distance x arrow will be equals to 10.5 divided by sine 49 degrees. Okay. Now using your scientific calculator, sine 49 will give us that will be, so this will give me 10.5 divided by 0.755. Okay. So when I divide it now, 10.5 divided by 0.755 will be, so that will give me 13.91 kilometers. Okay. All right. So I've obtained the shortest distance between the pilot and the base of the control tower as 13.91 kilometers. Okay. All right. Please observe that. That is it. So I can say therefore the shortest distance between the pilot and the base of the control tower is 13.91 kilometers. All right. Okay. That's 13.91 kilometers with shortest distance. Now, how do we find the height of the control tower? We still come back to the triangle. XY arrow. Okay. Now, this is the adjacent side and this is the opposite side. The opposite of adjacent is tangent, the tangent of the angle. So in this case, we'll be making use of TOA. That is tan 49 degrees will be equals to opposite of our adjacent. Okay. So quickly, let's look at that. So I can say that tan 49 degrees will be equals to the opposite side over the adjacent side, which is the opposite side is distance xy, and adjacent side is distance y arrow. Okay, so that is xy now is 10.5 divided by y arrow is 7.634 plus h. Okay, so if I then interchange positions with this, I can cross multiply. If I choose to, that is 7.634 plus h multiplied by tan 49 degrees is equals to 10.5. So if I divide by the coefficient of this, the coefficient is tan 49. I'll say that 7.634 plus h is equals to 10.5 divided by tan 49 degrees. Okay. So I'll have that 7.634 plus h is equals to 10.5 divided by tan 49 will give me that is 1.1504. So that will be 7.634 plus h is equal to, when I divide it now, so this will give me 9.127. Okay, when I divide it, then I collect like this, carry this one over here. After that, h is equals to 9.127 minus 7.634. Okay, so my height h will be equal to, when I divide that, that will be, this will give me 1.493. okay, in kilometers. 1.493 in kilometers. That's the height of the control tower. I say therefore the height of the control tower is 1.493 kilometers. All right, so that is it. So if you observe now, we have solved everything and the answers look similar to method 1. The height of the control tower is which is 1.493 kilometers. It's just similar to what we solved in method 1. All right, so that is it. Okay, so we made the subject of Formula, we had this 1.493 kilometers. Okay, we also got the shortest distance between the pilot and the base of the control tower as 13.91 kilometers. Okay, all right. Okay, I think we'll be stopping here for now. And we have also gotten distance xt. Of course, we got the value of distance xt. All right, I think we'll stop here for today. Stop here for now. Okay, stop here for now. This is it. So that's the diagram. The pilot is over there at the airplane, and this one shows you the tower. That's the diagram. Okay, so whenever we are teaching, please ensure you have a note and a pen and you are taking down notes. You are copying so that later you go back and study and understand it better on your own. All right, thank you. This is Mathematics Made Easy by Prosper Nodi. Mathematics Made Easy by Prosper Nodi. Please do well to subscribe to this channel and also share with your friends, and also to like the video. Whenever you are watching, please. Yeah. Thank you very much. Okay.